You ever been stuck in a maze? You know, that moment where you have to decide, do I just pick one path and hope for the best, or do I try to systematically check every single turn? Well, computers face a really similar dilemma all the time when they're searching for stuff. So today, we're going to dig into a super clever strategy they use to find their way, and it's got a lesson for all of us.
Let's start with a classic problem, right? So picture this. You've got to find one single file buried somewhere in this massive digital labyrinth of folders. You've basically got two ways to go about it. Do you dive deep down one specific path, just hoping you strike gold? Or do you meticulously check every single folder at your current level before you dare to go any deeper?
This is a huge challenge in computer science, and for a long time, there were really two main ways to tackle it. The thing is, each one came with a pretty major flaw. So let's break this down.
Okay, so on one side, you've got Depth-First Search, or DFS. Think of this one as a sprinter. It picks a path and just goes for it, full speed ahead. And that's great, because it's super light on your computer's memory. But what's the risk? Well, if it picks the wrong path, it could just run forever down an endless rabbit hole and never find the answer. Then, on the other side, you've got Breadth-First Search, or BFS. This one's more like a meticulous detective. It checks every single clue at level 1, then every clue at level 2, and so on. It is guaranteed to find the best, most direct answer. The catch? It has to keep track of every single place it's been, which can just eat up all of your computer's memory.
So what are you going to do? Are we just stuck choosing between a reckless sprinter who might never finish the race and a memory-hogging detective who always cracks the case but costs a fortune? Well, this exact dilemma led to a really, really clever hybrid solution.
Okay, let's bring out the hero of this whole story, the algorithm that manages to solve this puzzle.
It's called Iterative Deepening Depth-First Search. Yeah, it's a mouthful, so we'll just call it IDDFS. And the name itself kind of gives away the secret sauce. It basically takes the speedy, memory-saving strategy from our sprinter and combines it with the guaranteed to find it thoroughness of our detective. So how does it actually pull this off? I mean, it sounds kind of like magic, right? Let's walk through a quick visual example to make it totally clear.
Okay, so here's our search area. A simple tree of connected nodes. And our mission, should we choose to accept it, is to start at the top at node A and find our way to the goal, which is node I.
You know, the core idea here is actually super simple. It's really elegant. Instead of just searching forever, we search in these little rounds, or iterations. For each round, we put a leash on our search. We tell it, okay, you can look, but you can't go any deeper than this. If we don't find what we're looking for, no problem. We just give it a little more leash, and we start the whole search all over again from the top.
All right, let's start at the very beginning. For the first round, the depth limit, our leash, is set to, well, 0.
Yeah, with a leash that short, the algorithm can only check the starting node itself, node A. And since A isn't our goal, that's the end of round 1. Easy enough, right?
Okay, now things get interesting. For round 2, the algorithm bumps that limit up to 1.
Now, this is the really important part. It starts all over again from the top. It checks A again, and then it explores one level down, visiting B, then C, then D. It's still doing that memory-saving depth-first thing, but because of that leash, it can't wander off and get lost. Still no goal, so on to the next round.
Okay, round 3. You guessed it, we're increasing the limit again, this time to 2. And again, we start from scratch at the top. The search now explores paths that are 2 levels deep. It'll go down A, B, E, then A, B, F. Then it'll backtrack and try A, C, G. And finally, it explores that last branch. It goes down A, D, H, and then A, D, I. Bingo! We found it! And the second it hits that goal, bam, the whole search stops. It doesn't waste any time or energy exploring those deeper levels where J, K, L, and M are, because it already knows it found the shallowest and therefore the best solution possible.
So you might be thinking, wait, isn't all that restarting and rechecking the top levels kind of wasteful? And that's the surprising part. Let's talk about why this winning formula is actually so powerful and efficient. This whole idea is the key. It prevents the algorithm from ever getting lost down some infinite path, while still methodically and completely expanding its search area. It's like, instead of just sprinting into the dark, you take a few steps, turn on a flashlight, look around, and then take a few more.
So if you put these 3 head-to-head on a scorecard, the genius of IDDFS just pops. First up, is it complete? Meaning, is it guaranteed to find a solution if one's out there? Yes, absolutely. Just like our thorough detective. Next, is it optimal? Will it find the best, shallowest solution first? You bet, because it's exploring level by level.
And the big one, what about space usage? It's low, just like our memory-saving sprinter. It really is the best of both worlds.
Okay, so why should you care about some nerdy computer algorithm? Well, this isn't just a clever piece of code. It's a really powerful way of thinking about how to solve tough problems.
It teaches us that sometimes just restarting a process with a little bit more information, a little more range, is way more efficient than just committing to a single, potentially flawed strategy right from the get-go. You see this in artificial intelligence for games like chess, where a computer explores a few moves ahead, learns, and then goes a little deeper on its next pass. It's all about controlled, methodical exploration.
And really, this idea of iterative deepening applies to, well, pretty much everything. Think about learning a new skill, or researching a really complex topic, or even building a business. Sometimes going all in on just one path is super risky. A better approach might be to explore a little, learn from it, reset, and then go a little deeper. So think about it. Where in your life could this patient, step-by-step approach be way smarter than just a brute force one?